Hey guys, so this is a crash course on OAuth where we will try to cover everything you need to know about OAuth. So if you are able to complete this course, you will have all the knowledge on OAuth. So let us get started. First, let us talk about what is OAuth. Well, it stands for Open Authorization and it's a standard protocol. When we say protocol, it means it is a set of rules. And these rules actually allows any applications or any client to access some resource or data on behalf of a user. So we don't actually need a user, we need some kind of client who will act on behalf of a user, and the advantage of this will be that you don't need to know their credentials to access the data. One more advantage of OAuth is it can also provide something called as access level authentication, which is like instead of giving an app full access to your account, OAuth can allow you to grant permissions for only specific actions like reading your contacts or accessing your calendar. It means that unlike username and password kind of authentication where you will have complete control on the data, OAuth has a mechanism by which you will just be able to access specific set of data. So this will make your data more secured. So let us understand the same thing using a diagram. So let us say there is a client who wants to access some data from a server. So ideally what should happen? This server should only be accessible by a user who is actually having a username and password or some credentials on this server. So let us say there is a user who can access the server data. If this user is able to give its username and password to this server, it will be able to access all the data on this server. But this is called basic authentication. But what happens in OAuth is your user will not send its username and password. Instead of that, your user, who is the actual user of this server, will create a client app on this server. So there will be a client app and this will be created on the server, and this client app will have its own ID and secret. This ID and secret is different from the username and password, and it will also have something called a scope. So this ID and secret will be used to identify this client, and the scope will use to identify what are the different permissions which this client have on this server. Okay, so this is how it allows only certain set of permissions which we were just talking about when we said that instead of giving an app full access to your account, OAuth will allow to grant certain permissions or actions for your APIs or services. So this scope will define those permissions. Now this client can make use of this client app and make a request to this server to get the data. Now let us see an example of OAuth which we generally see in our real life. So when you log into a website using Google, you don't provide the website with your Google username and password. Instead of that, the website asks Google that can you log in using your Google account, and you as the user approves it. Okay. So when we talk about this server is Google. The client is something like, okay, let us take an example of Spotify will be a client and you will be the user. So Spotify will try to access some data from Google server, basically your username, your email, your profile picture, these kind of data Spotify will try to access to make a login using Google on Spotify. So you as a user will grant those permissions, so that will basically behind the scene create a client app, and this client app will be associated with Spotify. Well, this might sound complex, but it's a very easy process which I will just show you. So let us go to web browser, and I am on the accounts.spotify page. So if you notice, we are trying to log into Spotify and we have certain methods: continue with Google, continue with Facebook, continue with Apple. So let us start with continue with Google. So when we click on continue with Google, we will be prompted to choose our account. So let me choose my account. So, and when I choose my account, it will say by continuing, Google will share your name, email, language preferences and profile picture with Spotify. Well, Google have all your data, your photos, your emails, your name, email, language preferences and profile picture. All these things are with Google. But Spotify can only access those data which you can see right now: the name, email, language preferences and profile picture. This is what OAuth does when it says that I have a feature which only allows certain permissions. So first thing which you need to notice is the URL. You see, it is a OAuth URL for Google, where Google has created a client app, and this client app will have only permissions for these data. So well, I'm not doing that for now because I don't need to log into Spotify, but I think you understood that, right? Let us see, why do we actually need OAuth? Well, the first thing is security. When we talk about OAuth or any kind of authorization, we always deal with security. So when we say security, so instead of giving your password to every app, your server can still share data with different third-party applications only by authorizing them, which we just saw. So Google can share your data to Spotify just by authorizing it and without even sharing your username and password. Second is limited permissions. There's also one more feature called as limited permissions. Google was trying to share your data, but only certain set of data like your name, email. It was not try to share your Google photos with Spotify, right? So these are the data which you can share with Spotify to allow Spotify to log in. The next one is token based access. So when we say token based access, you do not need to provide any credentials to a server to access its data. You just need to provide a token. This token will first be given to you by the server itself once you are performing all those authorization tasks. We will see how it works. So once you have a token, you can use this token to make your API calls, but this token can either expire or can be revoked. Revoke means you can manually revoke this token. For example, when Spotify try to access a data from Google, so what Google will do, Google will actually give it a token. So let's say the token value is 123. Now what you can do later on is you can log into your Google account and revoke this 123 token. So if you revoke this token, so Spotify will no longer be able to access your data using this token. And other way a token can be invalidated is expires. So let's say your token is 123 and this token is made to expire in 1 hour. So every API call which you make for 1 hour will be valid, but after 1 hour, this token will be invalid. So the server or the Google server or any server will not accept this data. Now let us talk about some key players or key terminologies which we have in OAuth. The first one is resource owner. So when we say what is resource owner, it is the user who owns the data or the resource on the server. So the example which we saw is we had a client Spotify, we had a server Google, but the user, this is the user who is called the resource owner, and this is us. We are the one who owns the data, so we are called resource owner. Okay. Next one is client app. So basically the client app is nothing but the application which wants to access the data on behalf of a user. So if we see our example, we had a user and this user will create a client app. This client app will be used by Spotify to access the data from Google. So basically this client app is acting on behalf of this user to access the resource or the data. Now let us talk about the third player, which is the resource API. The resource API is a server that is hosting your data. So in our case, in our example, the resource API or the resource server is actually the Google server. Google server has all the data, everything hosted inside its own server. Okay. The next is the authorization server. Now the authorization server is a server that is verifying your identity, verifying the user's identity and the client app, and will also grant the tokens to the client app which will be used by your client to access the resource server or the data. Okay. So in our case, this server, the Google server, is also the authorization server. And so it will look something like this. It is the authorization server. It is also the resource server. Okay. So it is a big server which is having the resource as well and your authorization as well. So this user will be authorized using this authorization server. This client app will be authorized using this authorization server. Okay. So this authorization server is also very important. And the last one is the access token. Now the access token is the actual temporary key or the token which is issued to a client from the authorization server to access the resource server. The resource server has the data and the authorization server will store and verify the data of a user and a client to actually allow a resource server to be used. Okay, so now let us try to understand how does OAuth work. I have broken the working in a simplified flow, so let us try to understand it. So first thing is the app request authorization. So which app? This is the client app which the user will create on the authorization server. Okay. So this app will request some authorization from the user. So this app will make a request permission from the user itself to access some specific data. So when we are trying to do the OAuth procedure using Spotify, we saw that there was a page which was asking our permission that do you want to allow the name, email and other details to be read by Spotify. So that was actually the application which was asking permission from us. Okay, so this is the first step. The second step is you need to grant the permission. So the user means us, we will grant the permission. So the user logs into the resource provider, that is Google. So we logs into the resource provider, that is the Google server, Google resource provider, and then we give the app permission to access the data. Now the third step, since we have allowed our application to access the data, the app receives an authorization code. So the moment the user grants the permission, the application will get an authorization code. And this step actually is different for different type of grant types. So you can say all the steps, mostly all the steps in the OAuth is same, but this particular third step is different depending upon grant types. So I will explain you what is the difference when we talk about the grant types. So I will talk about all the grant types and what is the difference between those grant types. So suppose we have got the code. So fourth step will be the application, the client app will exchange this code for an access token. So the client app will actually send this authorization code to the authorization server, and the authorization server will give back the client app an access token. And this is the access token which is required for a client app to access the resource server data. So now the next step is the fifth step. The app will access the data using this access token. Okay, so basically the app can use the access token to access your user's data which is lying on the resource server. And one more thing which we need to know is the access token can expire. So access token usually expires after some time. In that case, the application or the client app can use the refresh token to get a new access token without actually bothering the user. So what does it mean that without bothering the user, we are getting a new access token? Well, if you see the steps, in the second step, we are actually asking the user to grant us the permission, right? And now we don't want to do this every time, right? So in that case, in the step number 4, when the app is exchanging an access token from the authorization server, the authorization server also gives something called as refresh token. And using this refresh token, you can actually create another access token without actually following all the steps where you are asking the user to grant those permissions. So this is how OAuth works. Now let us talk about the next concept, which is grant types. Well, in OAuth 2.0, grant types are different methods which are used by client applications to acquire an access token. So when we talk about OAuth, this is just one thing. We just need the access token. And when we have the access token from the authorization server, we can access any data from the resource server. But the main fight is how to get the access token from the authorization server. And that is where grant types come. Grant type defines different methods by which we obtain the access token from the authorization server. Each grant type requires a specific flow for retrieving the token, and this is based on the application's use. It depends upon the use case that which grant type we should choose. Different use cases can be like user authentication, or it is a server to server authentication or communication. So let us see what are those different grant types and where are they used. So this is the complete list of grant types which you need to know, and these are total 7 grant types. First one is the authorization grant type, second is the authorization grant type or authorization code grant type with PKCE. Third is the implicit grant type. Well, this is not used now, it is deprecated, but we will still see what are the concept of it. Fourth is the client credentials grant. Fifth is the resource owner password credentials grant. Well, this is discouraged because it is not too secured. Sixth is the refresh token grant, and seventh is the device authorization grant. And this is for a device flow. We will see each grant type, how it works, and where are they generally used. Now let us talk about the first grant type, which is the authorization code grant type. Well, this is the most secured and most commonly used grant type, and it is mainly designed for applications that have a backend. For example, a web app or a mobile app with a server which has a backend can use this particular grant type for OAuth Flow. Now, this flow involves exchanging an authorization code for access token, and the access token is what we need to access your resource data. So let us see this with an example. So let us say you are a client. Let us say this is a Spotify client. So this Spotify client want to access some data from your Google server. So let us say this is your Google server. So Google and server. Let us say this is having your resource server, which is having your data inside it, and an authorization server. We as a client or Spotify as a client want to access the resource server, but it should firstly have the access token. So how will this get an access token? Well, Spotify creates a client, and this client will be used to access your resource server. So firstly, this client will make a request to the authorization server, and it will say, get me the authorization code. Well, firstly, it will need the authorization code, but for that, whenever the client will send a request to the authorization server, this will be redirected to the user. Now the user will have to approve this request. Once the user approves this request by saying, okay, continue with these details, the authorization server will return the client or this Spotify server that, hey, this is your code or authorization code. Now Spotify can take this code and give it to the authorization server again, and this time it will ask for the access token. And this time the authorization code will give Spotify the access token, and the access token is what the Spotify client needs to access your resource data. The Spotify client can now take this access token and give it to resource server, and resource server will give back the data. So this is the complete thing called as authorization code grant type. So now let us see this again. So how the authorization code grant type works? Well, you have to understand this very clearly because this is one of the most used grant types. So it has major two stages. Firstly, the user authorization, and secondly, the authorization code exchange. In user authorization, this is a front-end interaction in which the client application or your mobile app or web app will redirect the user to the authorization server. For example, your Google or Facebook or whatever server you are authorizing from. And this will be a specific URL. How this URL is made, let us see. So for example, https auth.example.com is your authorization server. So you will say slash OAuth slash authorize. So this is your authorization server. And in this, you will say response type is equal to code. You will have a client application. That client application will have a client ID. So you will also send the client ID. You will set the redirect URI. We will see where this is used. And we will see the scope. Well, the scope will define what are the different permissions you are asking. When the client app will hit this URL, it will be redirected to the authorization server, and in the user interface, the user will have to approve this request. So once the user will approve this request, see, that is the second step. The user is actually prompted to log in and approve the requested access. So if the user is already logged in, they will just need to approve the authorization request. And once the authorization request is approved, the authorization server will actually redirect the user back to client applications. And where will it redirect to? This is the redirect URL where you will be redirected to. Okay. Now, for example, this is your application which you gave as your callback URL or redirect URL. Now, when the Google server or the authorization server will redirect it, it will also send the code in the query parameter. And this is your authorization code. And what is the advantage of it? See, the main advantage is the access token was not directly given in a browser. So anyone who is trying to hack into your system or trying to, intercept into your network, they will not get the actual access token. Now the next step is authorization code exchange. Well, now the client app is having the authorization code. What the next step will be? Now the client application will make a post request to the authorization server endpoint, and this time the request will be a little different. This time it has to pass the authorization code, client ID and client secret, and the same redirect URI. This can look something like this. You will make a post request to this. This is your authorization server, https:/auth.example.com/auth/token. You can send your data in application form encoded or JSON format, whatever the authorization server is expecting to. In the grant type, you will write authorization code, and you will also pass the authorization code, your redirect URL, your client ID, and your client secret. Once you pass these details, the next step is the authorization server will validate this particular authorization code, and in exchange it will give you access token. Okay, and the response can look something like this, where you will have the access token, you will have the token type which expires in, refresh token, and what are the scopes involved. For example, if the scopes are https google api/user info, and it is user info.email, user info.profile. So this token, this particular access token can only access the user information profile and user information email. So it can access your email ID, it can access your name, but it cannot access your Google Photos. It cannot access your actual emails which you have got in your Gmail. So this is how the scope works. The expires in is generally in seconds. So 3600 means 1 hour. This is a bearer token you have got. We will see how we use it. And this is the actual token. And we have got a refresh token as well. Well, refresh token, if you remember, it is used to regenerate your access token because your access token will expire in 1 hour. So you will have to regenerate it. So that is a separate thing, that is a separate grant type, refresh token grant type, which we will see. Next, now this time your client already has your access token. You have access token, right? You can make use of this access token and actually make an authenticated request to a protected server or protected resource server or data. You just need to pass in your header a key called as authorization, and the value will be your access token. And since this access token is a bearer token, you have to pass it like bearer space your actual token. Okay. So this is how the complete authorization code type works. Now let us understand the best use cases where we actually use the authorization code grant type. The first is the web applications. Well, in web application, you generally see that we are having OAuth server with authorization code grant type, where you will be redirected on a URL. You have to provide your consent or approval, and then that server will be able to access your Google data or Facebook data or other kind of API, whichever you are using. It is also used in mobile apps, which has a secure backend server, or any third-party app that needs to access your user data from other platforms like Google, Facebook, GitHub, right? Let us see an example scenario. So if you talk about an example scenario where OAuth is in action for authorization code grant type, so let us say you are developing an application called as Event Master, and this Event Master is an application which wants to use your Google Calendar to create some events for you. Okay. So the first step will be you have to sign in with Google. So when you have this event master application, you will have a client application, and this client application will redirect your user to sign in with their Google, and they will be redirected to the Google server, and the user has to log in and grant that permission, whatever permission you want to access. Well, you have to write the correct permissions like accessing their calendar. This is the authorization code grant flow. Now, after the user has approved this request, Google sends an authorization code back to Event Master's redirect URL. Now, Event Master, since it is a backend server, can make use of this code to request an access token from the Google. And this time what it can do, once it gets the access token from Google, now it can make API calls to access your Google Calendar data using the access token. And the advantage which we have got using this particular grant type is that your access token was never in the hands of your browser and or end user directly. It is only stored by the secured Event Master server, and only Event Master is using that token to access your Google Calendar data. Well, this is all about the authorization code grant type. Now let us talk about the second grant type, which is the authorization code grant type with PKCE. Well, PKCE stands for Proof Key for Code Exchange, and we call it like PKCE. This is very much similar to authorization code grant type. So I will just explain you what's the main difference between authorization code grant type and authorization code grant type with PKCE. Well, the first difference is the use, where it is used. So it is mainly used for public clients such as mobile apps or JavaScript applications or any applications which cannot securely store some secret values. So what PKCE does is it mitigates the risk of authorization code interception attack. Basically, it means if the authorization server has given a server the authorization code, and if this authorization code is being intercepted by some hacker, then this is like authorization code interception attack. So PKCE help us to fight with these kind of attacks and mitigates the risk of these kind of attacks. It introduces an additional layer of security where the client app generates a code challenge and verifies this code challenge during the token exchange process. So let us understand it with an example, and you will understand what's the main difference between authorization code grant type and authorization code grant type with PKCE. So the flow is very much similar. Firstly, the client will initiate a request which will be redirected to a user, and the user will have to allow this or approve this request. But the request will include some extra things. Those are called code challenges. So suppose this is your authorization server, and there is a request made to this authorization server, and this the response type is code. we send the client ID, we send the redirect URI, we have to send the scope. So these four things are common in authorization code grant type. But we also send two more things. So the client will also send two more things called as code challenge and code challenge method. Code challenge is a random string, and this is a hashed string of a code verifier. The code verifier is a random string which gets generated, and we hash this value and send it to the server. And we also send the server which kind of hashing algorithm which we used. So we used S256 algorithm. So the server knows that okay, S256 is used to hash this. Next, the user will authenticate and authorize this. This is similar to authorization code with grant type. Now the server will call your redirect URL with the code, and you have got your code, right? Till this step, everything was similar apart from these two things which we just sent. Now the client will try to exchange this authorization code for access token. In this step, the main thing is the client will make a post request to the authorization server. It will send the grant type, the client ID, the code, the redirect URL. Again, all these things are similar in authorization code grant type, but it will also send the code verifier. Now this code verifier is the original random string. Now you will have to understand this. Firstly, it sent a code which is the hashed value. This is the hashed value, and it hashed it using S256. And now the client will send the original code. This is the original code which the client hashed in the first place, and now it will send the original code. What the authorization server will do? The authorization server will try to use this particular value and hash this value using S256, because originally it got the request with S256 algorithm that okay, this code challenge is hashed using S256. So now since you need the access token, you will have to send the code verifier. I as the authorization server will hash this code verifier using S256, match it with the original request code challenge, and if it will match, then only I will send you back the access token. So this is like an extra layer of security which ensures that the second request where you are exchanging the authorization code with the access token is coming from the same server or the same place, and not any hacker who has intercepted the authorization code. And then you will get the response. Once you get the response, this will be very much similar to authorization code grant type. So let us understand a practical use case of this. Imagine you are developing a mobile app called as FitTrack, and this has to integrate with Google APIs to access some users' data. Now, since this is a mobile app, so it is a public client, and public clients are not the best place where secrets are stored. So in this case, generally we use authorization code grant type with PKCE to add an extra layer of security. How this scenario works, let us see. So FitTrack app will generate a code verifier and a code challenge when the user will start to log in. So whenever the user is redirected to Google to log in, it will also have the code verifier and the code challenge. Now the user is redirected to Google to log in, and once the user has approved this request, Google will send this authorization code back to fitness track application, and now the fitness track will try to exchange the code with the access token by sending the code verifier as a proof that okay, I am the correct client, or I am the one who actually sent the original request. Google will verify it and send you back the access token, and now you can use, or fitness track can use this access token to access the data and perform whatever it wants to do. So this is all about authorization code grant type with PKCE or PKCE. Well, PKCE stands for proof key for code exchange. Now we will talk about the next grant type, which is implicit grant type. Well, this is not used now, it is deprecated, and its better version is what we just saw, authorization code grant type with PKCE. So for this one, we will just go through it, but we don't need to go in deep for this because this is not used now, it is deprecated. So just for understanding, let us see what is the flow involved in implicit grant type to get the access token. So this is your authorization server, and the client application will make a request to this authorization server, and along with the request it will pass this response token, client ID, redirect URI, scope, and something called as state. Now you can see this is very much similar to authorization code grant type which we just saw. So you send the client ID, the redirect URI, the scopes, but this time in the response token you are directly sending the value token and not code. it means you want the token and not the code. And state is just an optional parameter, so for that we don't need to worry about. The main thing which we need to understand is the response type is token in this case. So when it is token, the authorization server will return back you a token. So that's what written over here. Instead of providing an authorization code, it will directly include the access token in the URL fragment. So the response back from the authorization server will be to your callback URL or redirect URL, the access token directly. And this is a type of bearer, expires in 1 hour, and it has a state. Well, you can think that, hey, this is very much straightforward, but again, this is not that secure because this response can be intercepted by a browser and they can take your token and they can access your data. And that is why this got deprecated, and its better version is authorization code grant type with PKCE. So this was actually used in single page application, mobile application where there was not a backend server which can store your secrets. So now this is replaced with PKCE, authorization code grant type with PKCE. So the next grant type is the client credentials grant type, and this particular grant type is mainly used for server to server communication. So it allows a client application to obtain an access token by directly authenticating itself with the authorization server, and that too without any user interaction. So let us say we have two different services, service 1 and service 2. Service 2 is having some data exposed in its resource server, and let's say it has a resource server and an authorization server. The service 1 wants to use the data from the resource server of service 2. In this case, a good choice is a OAuth grant type with client credentials. So what will happen is, in the authorization server of service 2, we need to create a client application, and this client application will have two things, a client ID and a client secret. Now this client application can be utilized by the service 1 to make a request to the authorization server to obtain the access token. An access token is what we need to access any data from the resource server. So once we have this access token, we can make a request to the resource server using this particular access token, and we will get back the data. But this is mainly designed for a service to service communication, and there is no user interaction involved directly. So the client credentials grant type flow works in the following ways. So before using the client credentials grant type, we should have a client application. What we just saw that, okay, we have to get a client application in the authorization server, and this must be registered with the authorization server. Now during registration, we obtain a client ID and a client secret, just what I told you. Next is we will make a token request. So to get a token, we have to make a post request to the authorization server's token endpoint. All right. And we have to provide three important details. Those are grant type, client ID, and client secret. So the client application makes a request to the token endpoint of the authorization server to obtain the access token. All right. So access token is what we need. So we will make a post request and we'll pass few important data, that is the grant type, client ID, and client secret. The value of grant type will always be client credentials, and the client ID and client secret will be obtained using the client application, which we will have to create on the authorization server. Next, when we make this request, the authorization server will give a response, and if the client credentials are valid, then in this case the authorization server will respond with an access token. All right. Now this access token is typically a JSON web token or a bearer token. So it will be specified in the token type of the response. So a typical response looks like something like this, in which we will have an access token, and this access token will be of, okay, bearer type, and it expires in 3600 seconds. All right. In few scenarios, we might get the refresh token as well. Let's make an example API request to fetch the data. And in this case, let us say this is our endpoint, or this is the resource server data. So we can just pass the access token which we just got in the header as authorization and bearer space the actual token. It's that simple to get the token in client credentials and use it to get the data. Now, you might think that, hey, this looks very much similar to implicit grant type, which got deprecated, because in implicit also we don't have any user interaction. We can directly call the authorization server and get the token. But the difference is, implicit one was mainly used for single page application where there was user interaction. But the client credentials is actually made for server to server communication. So there is a secured server which is using this service, hence the token is never compromised. Suppose you have a service and it has some kind of data with it, and you want to fetch this data on a scheduled basis like every 1 hour and put this data into a database. So in that case, client conditions can be a good choice because you can use client conditions again type to access the data from this service, create another service which can fetch the data and push it back to database. So this is how client conditions grant type work. So the next grant type is the resource owner password credentials grant type. Well, this grant type doesn't have a great security, so it's very highly discouraged. But just for the sake of understanding, we will see how do we obtain the access token and where are some typical scenarios where we can use this particular grant type. This grant type allows a client application to directly exchange the username and password of a user for an access token. So now you might think that, okay, if we are having a username and password and we are exchanging it for access token, now this is like a security threat, right? So we only use this grant type for trusted applications or native desktop or mobile applications where the client can securely store the user credentials and handle them securely. So only if you are trusting the application, then only we have to use this particular grant type. So how do we obtain the access token in resource owner password credentials grant type? So in this one, we will have a client application which will send a request to the authorization server token endpoint, and it will include the username and password as well as the client ID and client secret and the grant type. The grant type value will always be password in this case. So a typical request will look something like this: a post request to the authorization server, and this time we will pass the grant type as password, the client ID and client secret of the client application, and the username and password of the user who has created that client application. Now, the authorization server will authorize or authenticate this particular request, and in this case, it will issue a token. Now, this token will be only be issued if all the credentials given are correct, and this token will include the access token, the token type, which is like bearer or JWT, whatever the token type is. Generally, it is bearer type. Expiration is generally in seconds. Then we have some scope is like defining what data can this particular access token access, and the refresh token, which can be used to get a new access token. If you have a protected resource or the resource server at this particular host, you can just pass the header as authorization and the value as bearer space the token, and this way you will be able to get the data from the resource server. But I have already told you that this particular grant type is not very highly secured. So this should be used with some good security considerations. So the first security consideration which we need to have is that the client application will be handling the user's credentials. Now in this case, you will have to trust your client. So it's generally not a public client, it's generally an internal client which mainly use this particular grant type. But even if it is a trusted application, nowadays we generally do not consider this grant type to be used. In any case, we just go with authorization code grant type or authorization code grant type with PKCE whenever possible, because the resource owner password credentials grant type is actually bypassing a lot of OAuth security features, and that is why it's better to use authorization code grant type with PKCE in these kind of situations. Okay, so the next grant type is the refresh token grant type. Now, this is a special kind of token in OAuth where a client will make a request to obtain a new access token without requiring the user to re-authenticate. Okay, so think about it. When we perform OAuth using authorization code grant type, we typically get a response like this where we have the access token, we have the token type, we have the expiration, and we have the refresh token. So the access token is what we need to access the resource data, but the access token gets expired in 3600 seconds, that is 1 hour. So after 1 hour, normally if you do not have a refresh token, what you need to do is you need to follow all the process again of obtaining the access token using authorization code grant type. Now this will require a user, right? But if you don't want a user involvement again and again after every 1 hour, what you can do is you can make use of this refresh token. So once you have this access token and the refresh token, you can make a post call to the same authorization server, and this time you will have to pass the client ID, client secret, and this time you have to pass the refresh token as well. And in the grant type, you will have to specify that this is a refresh token grant type. Once you make this request, you will again get a response like this above, but of course you will have a different access token. The value of access token will be different. Maybe the refresh token's value can change as well. It's not important. Refresh token can remain same as well, or it can change. But definitely the access token will be a new one. Now to understand its flow, let us see this again. Initially, we perform the authentication and we get the access token and refresh token as well. We use the access token to access our data, but the access token is valid for a limited time, for example 1 hour. So after 1 hour the access token will expire and you will have to again reauthorize to get the access token. Now to avoid this, to avoid any user interaction, we can make use of the refresh token and we can get a new access token. So that's what refresh token does. To get you a new access token, you can use a refresh token, and that's it. So finally we have reached to the conclusion of our OAuth crash course. Thank you for having patience to listen to me, and I hope that this particular crash course has given you a lot of clarity on what is OAuth, on everything about OAuth. So we did cover what is OAuth. We saw some important terminologies in OAuth, for example, authorization server, resource server, access token, refresh token. We did saw how OAuth works. We did saw about grant types as well, and we did saw the explanation of 6 very important grant types and its working. So I hope this might have covered a lot of things for you, but if you feel that there's something missing, or if you feel that there's something which you might want to know about or you didn't understood, you can just comment it down and I will make sure that you have the answers for those questions. So for now, I think you will have to accept my bye bye and I will see you the next time.